For 20 years, engineering teams safely single-sourced their analog components. If a system required proven precision or power control, you turned to legacy giants like Analog Devices or Texas Instruments, and the parts arrived on schedule. That model functioned flawlessly right up until a concentrated wave of global disruptions hit. The assumption of infinite inventory dissolved, exposing the single point of failure within global manufacturing. This chart shows exactly how that vulnerability played out. Average semiconductor lead times abandoned their historical 12-week baselines, spiking dramatically past a 52-week waiting period for critical integrated circuits. A 52-week delay on a single $2 transceiver breaks the entire chain. You miss your product launch timeline, your revenue forecast collapse, and your unfinished inventory piles up in warehouses. Component sourcing can no longer be delegated as a localized procurement task. Securing your supply chain is now a boardroom-level crisis concerning enterprise business continuity. You can see the physical toll of these shortages in high-volume sectors like automotive and industrial systems. These trucks are fully built out with steel and glass, yet paralyzed by the lack of a few basic electronics. To counter this, leading OEMs are shifting to a primary plus qualified alternative sourcing model. They are actively integrating emerging ecosystems, like Cosine Nanoelectronics, to secure a parallel supply path. The trade-off for this security is friction. Identifying an alternative vendor requires your engineering team to invest significant upfront time validating these new components in the lab today. But consider the alternative. If your team refuses to validate a secondary option today, your automated assembly line can freeze tomorrow, all because you couldn't source a single microchip. Executives are no longer prioritizing a cheaper bill of materials. The primary decision is whether absorbing short-term engineering friction is worth surviving the next supply shock. This matrix weighs the status quo against a dual-source strategy. Dual source requires lab time to test compatible components, like Cosine's RS485 transceivers. Status quo demands zero upfront testing, but forces emergency PCB redesigns. Dual source achieves seamless drop-in replacements, securing reliability without altering your circuit board. Securing a drop-in replacement takes real work, but scheduling a week of initial lab validation is infinitely cheaper than halting your entire product launch to re-engineer a board from scratch. This transition requires equal effort outside the lab. Your procurement department also has to overhaul how they evaluate and manage vendors. Adding procurement to our matrix, dual source demands buyers manage a secondary supplier. The status quo is simple until a shortage hits, throwing your factory into a 52-week blackout. By managing vendors, procurement achieves operational agility, securing faster delivery cycles when the primary supplier falters. To gain true supply chain agility, procurement teams have to accept a permanent increase in their daily operational complexity. Even with clear advantages, engineering managers often hesitate. Trusting an unfamiliar Chinese analog IC ecosystem to run strict industrial systems remains a significant hurdle. Yet manufacturing capability has matured significantly. The precision on these silicon wafers proves a deep electronics ecosystem capable of tight industrial tolerances. Alternative suppliers like Cosine close this trust deficit by leading with data. They provide transparent electrical specifications, complete quality certifications, and direct support from local engineers. In the modern market, brand familiarity does not guarantee delivery. Trust has to be earned through verifiable specifications, consistent reliability testing, and dedicated technical support. This quadrant chart maps the final choice, weighing production halt risk against supply chain agility. The single-source strategy sits in the danger zone with maximum risk. The dual-source model moves you into the optimal target zone, mitigating operational risk. Manufacturing survival now depends on high-degree supply chain optionality, which protects production far more effectively than simply hunting for the lowest component prices. If you are a high-volume OEM in the industrial, automotive, or medical sectors, where every delayed shipment means severe revenue loss, you need to adopt this dual-source transition immediately. Conversely, if you run a low-volume operation or lack internal engineering bandwidth to test new components, this strategy will drain your resources. Without the internal resources to rigorously validate component specifications in the lab, a resilient supply chain remains out of reach. But the ultimate goal of the dual-source mandate is this: a production line that runs flawlessly, immune to sudden shocks of global component shortages. The goal of qualifying suppliers like Cosine Nanoelectronics is never to replace your primary vendor. The goal is to guarantee that when your primary vendor fails, your factory floor never even notices.